Hi all, welcome to Anil Nair classes. Today in this session, we are going to discuss the divisibility rules session 2. In session 1, I am sure most of you have attended the class. In the session 1, we discussed divisibility rules for few numbers. I will repeat the important concepts. I discussed the divisibility rule for 2. 2 is nothing but the unit digit should be an even number including 0. I discussed the divisibility rule for 5 where the unit digit is 0 or 5. Then I told you that the 10 is nothing but the composite number which can be written as a product of two coprimes, that is nothing but 2 and 5. The divisibility rule of 10 is the unit digit should be 0. Then we extended the logic to 2 power n, 5 power n and 10 power n. Divisibility rule of 4 is last 2 digits should be divisible by 4. Divisibility rule of 8 is last 3 digits should be divisible by 8. Similarly, divisibility rule of 25 is last 2 digits should be divisible by 25. Divisibility rule of for 100 is last 2 digits should be 0 and 0. Last 2 digits of any number is the remainder when you divide a number by 100. Then we discussed the divisibility rule for 44, which is nothing but 4 and 11. Then we also discussed the divisibility rule for 18, which is nothing but 2 and 9. I also discussed the divisibility rule for 3 and 9. 3 and 9 divisibility rule is sum of the digits should be divisible by 3 and 9. Then I discussed the divisibility rule for 11. I discussed 3 methods. Method 1. Reminder 1, 10 square divided by 11, which is nothing but 1. Method 2, sum of odd places minus sum of even places should be divisible by, sum of even places should be divisible by 11 or it should give a difference 0. Then we discussed the divisibility rule for 7, 11, 13. Divisibility rule for 7, 11, 13. Some important conclusions which we have drawn. What are that conclusions? Start from the rightmost digit. Take a group of 3 digits. Alternatively add and subtract. That is the divisibility rule for 7, 11, 13 and the combinations, that is 77, 91, 143 and 1001. Any 3-digit number written even number of times is always divisible by 7, 11, 13 and combinations. Point number 2. Any non-zero singular digit written in groups of 6 is always divisible by 7, 11, 13 and its combinations. This is what we discussed in divisibility rule session 1. In session 2, I will explain how you can find out your own divisibility rules for any prime number. Very interesting class. But before we discuss the class, I want to tell you another important concept. Important concept. Now see here. Test for divisibility rule for 7. I am not going to discuss the theory of osculation right now. Very, very interesting concept. See here. I am not going to discuss this concept. A student from IIT has asked me this question. So I want to explain the beautiful concept behind it. Now see here. Divisibility rule. His doubt is from this concept. Divisibility rule for 3, 9. What we discussed for divisibility rule for 3, 9, I will do it for 9. I will write down the divisibility rule. If nothing is specified, it is in decimal system. In decimal system, the base value will be 10. There are 10 digits from 0 to 9. Suppose if I take a 3-digit number XYZ. XYZ is in decimal system 10. Z is in units place. Y is in tens place. X is in hundreds place. 100x plus 10y plus z. This can be written as 99x plus 9y plus x plus y plus z. Now if you observe carefully, XYZ base 10, if this is divisible by 9, 99x is divisible by 9, 9y is divisible by 9, x plus y plus z should be divisible by 9. X plus y plus z is nothing but the sum of the digits. Sum of the digits should be divisible by 9. Are you all with me? Sum of the digits. Extremely mesmerizing concept, sir. Sum of the digits should be divisible by 9 in base system 10. In base system 10. Now what I will do is, I hope it is clear. Suppose if I take in base system 5. In base system 5. This is 10 power 0, this is 10 power 1 and it is 10 square. This is 5 power 0, this is 5 power 1 and it is 5 square. So it is nothing but 25x plus 5y plus z. This can be written as 24x plus 4y plus x plus y plus z. Are you all with me? If this number is divisible by 5, this is, or if this number is divisible by 4, 24x is divisible by 4, 4y is divisible by 4, x plus y plus z should be divisible by 4. X plus y plus z should be divisible by 4. Listen carefully. I want each and every viewer to listen to the next two statements carefully. Statement 1. In a decimal system, if the left hand side is divisible by 9, sum of the digits should be divisible by 9. In the left hand side, if this is divisible by 4, x plus y plus z should be divisible by 4 in base system 5. In base system 5. Now, see here, listen carefully. Listen carefully. Suppose if it is in, if this is in, that means in a base system 10, in a base system 10, divisibility rule for 9 is, divisibility rule for 9 is, sum of the digits should be divisible by 9. Sum of the digits should be divisible by 9. What is the another example that we have taken? In a base system 5, the divisibility rule for 4 is, the divisibility rule for 4 is, sum of the digits should be divisible by 4. Are you all with me? That means digital sum concept can be applied for any base system. What is the concept? In a base system K, sum of the digits should be divisible by k minus 1. Please make a note. Digital sum can be done for any problem. In a base system K, sum of the digits should be divisible by k minus 1. Extremely important concept. Very, very important concept. Digital sum can be applied for any base system. In a base system K, sum of the digits should be divisible by k minus 1. Now, let us take few examples. Let us take, because you might think that it is only the divisibility rule for 9. We will discuss this theory of osculation little later, but before that, solved examples. I always believe that with examples you will get a lot of clarity. Solved example. 2, 3a in base system 10 is divided by 9. Find a value. Find a value. There is a number that is given that is divided by 9. When it is divided by 9, sum of the digits should be divided by 9. 2 plus 3 plus a should be divided by 9. 2 plus 3 is a. 5 plus a should be divided by 9. If 5 plus a is divided by 9, what will be the value of a? Value of a will be 4. Are you all with me? It's a very simple example where the divisibility rule for 9 is sum of the digits should be divisible by 9. 2, 3a in base system 8 is divided by 7. find A. 2, 3A in base system 8 is divided by 7, find A. What will be the divisibility rule for k minus 1 for base system k? Sum of the digits should be divided by, sum of the digits should be divisible by k minus 1. 2 plus 3, 5. 5 plus a should be divided by 7. What is a value? 2. I hope you have understood how to use these digital sum for another base system also. In divisibility rule for 9 is sum of the digits should be divided by 9. That is not only in a decimal system, in a base system k, divisibility rule for k minus 1 is sum of the digits should be divided by k minus 1. I hope you got the idea. One more example. 3, 4a in base system, 3, 4a in base system 9 is divided by 8. Find a. 3, 4, 9. A in base system 9 is divided by 8. Find A. What is the divisibility rule for k minus 1? Divisibility rule for k minus 1 in base system k is, sum of the digits should be divided by k minus 1. Sum of the digits should be divided by k minus 1. Sum of the digits should be divided by k minus 1. 3 plus 4 plus a should be divided by 8 in base system 9. 7 plus a should be divided by 8. What is a value? 1. I hope you got no idea. Anyway, in base system, I will use this fantastic approach where you don't need to find out the addition of two bases, subtraction of two bases. You can easily solve the question just by looking at an answer option. Are you all with me? Right? Now, one more. Suppose, because I wrote these test for divisibility rule for 7, let me use it. Suppose, see here, is, for example, a smaller number is given, is 98 divisible by 7. Is 98 divisible by 7. Just an intellectual approach. Is 98 divisible by 7? Most of the students will solve like this. 98 when divided by 7. 7 14s are 98, remainder 0. So 7 divides 98. This is a generic approach. Everybody knows about it. Suppose if Anil Nair is solving this question. Anil Nair's way of solving this question. Now see here. This is 98. 98 is in base system 10. What is the divisibility rule for k minus 1? Sum of the digits should be divided by k minus 1. Sum of the digits should be divisible by k minus 1. Because it is divisible by 7, if I am doing whether it is divisible by 7, I will convert into 8. How to convert a decimal to non-decimal? 8. 8 12s are 96, remainder 2. 8 1s are 8, remainder 4. Write down 142. 142. What is the divisibility rule for 7 in base system 8? Sum of the digits should be divisible by 7. 4 plus 2, 6. 6 plus 1, 7. 7 is divisible by 7. Therefore, 98 is divisible by 7. If you are good in concepts, this is how you can look at a simplest problem through a different prism altogether. Is 98 divisible by 7? 98 when divided by 7, remainder 0. Every Tom, Dick and Harry, any NCERT, CBSE, ICSE textbook teaches you like this. Anil Nair will teach you like this. 98 is in base system 10. I want whether it is divisible by 7. I know that the sum of the digits is divisible by k minus 1. This is the divisibility rule for k minus 1. For base system k. So I translated into base system 8. 98 when converted into base system 8. 8 12s are 96, remainder 2. 8 1s are 8, remainder 4. 142. Sum of the digits should be divisible by 7. I hope it is clear. If it is not clear, I will tell you as many problems as possible. I am doing it because I saw the heading as test for divisibility rule for 7 instead of osculation, base system conversion approach. Base system conversion approach. I will do 2 more problems so that it will be extremely clear to you. Solved example. Every class of mine will change the way you think about aptitude. Is 1225 divisible by 7? Is 1225 divisible by 7? Approach is 1225, it is in base system 10. I want to do it by 7, so I will convert into 8. Conversion means I have to divide it. 8 ones are 8, 42. 8 5s are 40, 25. 8 3s are 24, 1. 8 ones are 8, 73. 8 9s are 72, 1. 8 2s are 16, 3. Right from bottom to top. 2 3 1 1 base 8. What is the divisibility rule for 7 in base system 8? Sum of the digits should be divisible. 5 plus 2 7, so it is divisible. This is how I want you to think. This is how you want to think. In every, I discussed the divisibility rule for 7 as take a group of 3 digits, alternatively add and subtract, right? I hope 10 power 6 by 7 is 1. All these we discussed. This is a very different way of looking at. Trust me, mark my words. If you listen to my base system, you will be jumping out of joy and you will be thinking that, oh, digital sum can make the toughest of the questions to be solved in seconds. I hope it is clear. One more question I will solve. Is 232 divisible by 7? Is 232 divisible by 7? 232, I will divide it by 8. 8 2s are 16, 72. 8 9s are 72, 0. 8 3s are 24, 5. 350 when divided by 7. 3 plus 5, 8. 8 is not divisible by 7. So 232 is not divisible by 7. I hope it is clear. Idea clear. Are you all with me? I hope you are all there with me. Is it clear? Oh, this can be extended for any question, sir. Anything. Suppose, I hope you got an idea what is the entire concept that I used it, right? If it is he is asking you the divisibility rule for, suppose for example, is 372 divisible by, ఒకసారి కట్ చేయి. Is 372 divisible by 6? 372 divisible by 6. One approach, reminder 1. 372 divided by 6. 6 6 are 36. So reminder is 0. 372 is divided by 6. Are you all with me? Is divided by 6. First approach clear. Method 2. Method 2. Is divided by 6. So convert it into remainder 7. Base system 7. Sorry. Base system 7. So 372. 7. 7 5s are 35. 22. 7 3s are 21. 1. 7 7s are 49. Remainder 4. 7 1s are 7. Remainder 0. These are nothing but 1041. In base system K, what is the divisibility rule for K minus 1? Sum of the digits should be divided by K minus 1. 6 is divided by 6. That means from now onwards, to all the viewers who are watching the class, digital sum is not only applied for decimal numbers, it is applied for any base system numbers. The divisibility rule for 9 in base system 10 can also be concluded as divisibility rule for base system K minus 1 for the base Okay, I hope give a thumbs up once you have understood this logic. There is a tremendous satisfaction when you learn something out of the box. And in every class of mine, this is what I am going to tell you. Give me some hours of your time. I will show you aptitude through a prism you have never seen before. I hope you have understood this concept, right? Beautiful concept. Now I will discuss theory of osculation. Theory of osculation. By the end of the class, you will be able to find the divisibility rule of a prime number on your own. Theory of osculation is used to find the divisibility rule for a prime number. Divisibility rule for a prime number. By using this, you can find your divisibility rule for prime number. Prime number divisibility rule is an undecidable problem. Is an undecidable problem. What do you mean by an undecidable problem? A problem is said to be undecidable if there exists many ways to solve a problem. If there exists many ways to solve a problem, or if there exists no way to solve a problem. No way to solve a problem. Either you cannot find out a solution to a problem, or you can find out multiple ways to solve a problem. Then it is said to be undecidable problem. A problem is said to be undecidable if there exists many ways to solve a problem or no way to solve a problem. And examples of undecidable problem is how many numbers between 2 and 3. It could be 2.0, 2.0003 and so on. You cannot determine how many numbers are there between 2 and 3. How many stars are there in a sky? How many stars are there in a sky? How many points are there in a straight line? These are all undecidable problem. You can determine your own divisibility rule by knowing it. But before that, I will explain how a divisibility rule for a prime number is generated. Listen carefully, this is something which you will not get it in any of the regular textbook. Now, first we will explain the theory of osculation. Theory of osculation. Theory of osculation states B is the unit digit. B is the unit digit. A represents 1 digit, 2 digits. A represents any number of digits. A represents any number of digits. Any number of digits. It could be 1 digit if it is a 2-digit number. If it is a 2-digit, it could be 3 digits, anything. If AB is there, if you can find out the value of k satisfying this equation, if you can find out the value of k satisfying this equation, then you can find the divisibility rule for any prime number. Divisibility rule for any prime number. Divisibility rule for any prime number. Don't take the wrong information. I am not saying that AB is a 2-digit number. I am saying that the B is the unit digit. A could be any number of digits. If you can find out the value of k satisfying this equation, if you can find out the value of k satisfying this equation, the divisibility rule for any prime number can be obtained. Divisibility rule for any prime number can be obtained. Are you all with me? I will write down at the top, then I will do one by one. Theory of osculation. Theory of osculation. Theory of osculation is a very important concept. AB could be any number. A plus or minus k into B. It should be either 0 or AB. What does that mean? Let us see. 7. 7 is a single digit number. What is the next multiple of 7? 14. 14. Here B value is 4. A value here is 1. Can I write 14 as 1 minus 2 into 4? What is 1 minus 2 into 4? 1 minus 2 into 4 is minus 7. Is minus 7, is it divisible by 7? Yes. That means what is the k value we got here? K value we got here is 2. How does it helps? Suppose for example, 784 is there. 784. What we did in this example, we took the unit digit. We took 4. We multiplied by 2. So 4 2s are 8. We subtracted it from the remaining number. If you take 784, observe this example. What did I do? I took the unit digit. I doubled it. 4 2s are 8. I subtracted it from the remaining part of the number. I said that the A is the remaining part. 78 minus 8 is 70. Is 70 divisible by 7? Yes. That means 784 is also divisible by 7. I hope it is clear. So what is the divisibility rule for 7? Take the unit digit, double it, take the unit digit, double it, subtract it from the remaining part. You don't need to write it like this. Understand the value of k, everything else will follow. Remaining part it will be there. I will take few more examples so that it will be clear. Are you all with me? So that means test for divisibility rule for 7 says that k value is 2. That means divisibility rule for 7 is a minus 2b. A is the any number. Divisibility rule for 7 states if a could be any digit, the concept is a minus 2b. Concept is a minus 2b. For example, 2401. Take the unit digit, double it, 2. Subtract it from the remaining part, 238. Continue the process till you get a smaller digit number. Take the unit digit, double it, 16, 7. 7 is divisible by 7. That means 2401 is divided by 7. I hope the idea is clear. 2401 is divided by 7. One more example. Is 137 or 132? 132. Take the unit digit, double it, subtract it from the remaining part, 9. 9 is not divided by 7. So 132 is not divisible by 7. So the divisibility rule of 7 is, it should be there in your notes. It is a minus 2b. It is a minus 2b. Right? Probably at the end of the class you will be able to solve it on your own. Next one. Divisibility rule for 13. What is the concept theory of osculation? A plus or minus k into b should give you either 0 or ab. This is the theory of osculation. So 13 can be written as 13, 1 if I do plus. If I multiply the unit digit by 4, 4 3s are 12, 12 plus 1, 13. That means k value here it is 4. K value here it is 4. So the divisibility rule for 13 is a plus 4b. B is the unit digit. A could be any number of digits before b. A plus 4b is the divisibility rule for 13. Example 4225. 4225. 4225. Take the unit digit. Multiplied by 4 times. 5 4s are 20. Add it to the remaining part. Remaining will be 442. Take the unit digit. Multiplied by 4 times. 2 4s are 8. Add it to the remaining part. 52. 52 is divisible by 13. 52 is divisible by 13. So 4225 is divisible by 13. What is the divisibility rule for 13? Take the unit digit, multiply 4 times. You don't need to add it. Just write down it as an expression where b is the unit digit. A could be any number of digits. A plus 4b is the divisibility rule for 13. Are you all with me? Like that, if you get one more value of k, you will get another divisibility rule. If you get one more value, that is the reason I said prime number divisibility rule is not unique. A prime number divisibility rule is undecidable. A problem is said to be undecidable if there exists many ways to solve a problem or if there exists no ways to solve a problem, right? As the more and more digits increases, then the Fermat's theorem came into picture. Fermat's theorem is applicable when the number of digits are more. This theory of oscillation is helpful when the number of digits are less. Divisibility rule for 19. Theory of oscillation states if B is the unit digit, A could be any number of digits. A plus or minus K into B is either 0 or AB. Either 0 or AB. 19. 19 can be written as 1 plus 2 into 9. 1 plus 2 into 9 is 19. So here we are doing 2 into unit digits. So the divisibility rule for 19 is A plus 2B is the divisibility rule. What is B? B is the unit digit. A is nothing but any number of digits before B. I hope it is clear. Two examples which we will do. 1,444. 1,444. Take the unit digit, double it, add it to the remaining part. 4 2s are 8. If I add it to the remaining part, this will become 152. Take the unit digit, double it, add it to the remaining part, 19. 19 is divisible by 19. So 1,444 is divisible by 19. I hope it is clear. One more example. For example 441. 441. Take the unit digit, double it, add it to the remaining part, 46. Take the unit digit, double it, 6 2s are 12 plus 4, 16. 16 is not divisible by 19. I hope you are able to understand how am I deducing the divisibility rule for any number of prime numbers. Anything other than the unit digit, fix it. Find out the value of K. Just a little bit of calculation is required. Next one, divisibility rule for 17. AB, theory of oscillation. A plus or minus K into B, it should be either 0 or AB. Either 0 or AB. Either 0 or AB. 17. 1 plus K into 7. K into 7. Or it can be 1 minus K into 7. K into 7. Either it should be 0 or a multiple of 17. If I take 17, what should be the value of value? If I take K value 1, 7 plus 1, 8. If I take K value 2, 14 plus 1, 15. K value 3, 21 plus 1, 22. K value 4, 29. K value 5. If I take K value 5 here, in the second case, 1 minus 5 into 7. 1 minus 35 is minus 34. Minus 34 is divisible by 17. That means divisibility rule of 17 is A minus 5B. I hope you are all there with me. A minus 5B. It may not be plus K or it might be minus K. Suppose if it is 7225. 7225. What is the divisibility rule? A minus 5B. Take the unit digit, multiplied by 5 times. 5 5s are 25. Subtract it from the remaining part. So it is 697. Take the unit digit, multiply by 5 parts. 7 5s are 35. 69 minus 35, which is 34. 34 is divided by 17. 7225 is divisible by 17. I hope the idea is clear. Idea is to make a viewer find out the divisibility rule on your own, just with understanding of the concept. In our school days, at the age of 6 years or 7 years or 9 years, a particular concept only is taught because that was your intellectual level. But as you grow up, you should be able to question everything. This is exactly what I call it as a W and a H based learning. What, when, where and how. Where it is used depending upon the merit of the question, I will tell it. But if somebody asks you what is the divisibility rule of 17, if you are an Anil Nair student, you should say, according to theory of oscillation, this is the rule. According to Fermat's theorem, 10 power 8 divided by 17 is minus 1. Any single digit number written p minus 1 times is always divisible by p not equivalent to 235. Again I am explaining you, sir. Divisibility rule for 17. At least in my class I told you 3 methods. Method number 1, a minus 5b, which we discussed right now. Method number 2, 10 power 8 divided by 17 is minus 1. Method number 3, any single digit written p minus 1 times, any single digit written p minus 1 times, written p minus 1 times is always divisible by p not equivalent to 235, and p is a prime number. Depending upon the question, either you choose method 1, method 2 or method 3. Crystal clear clarity in any of these questions. I hope it is clear. That is exactly the reason you should not miss any of my classes. Are you all with me? Divisibility rule for 7. Divisibility rule for 23. My job is easy. Once the student understands the concept, a plus or minus k into b is 0 or ab. This is theory of osculation. 23 is nothing but 2 plus 7 into 3, which is 23. So what is the divisibility rule? Divisibility rule is a plus 7b. A plus 7b. I hope it is clear. For example, if it is 8464, a plus 7b, take the unit digit, multiplied by 7 times, 4 7s are 28. So these 874, take the unit digit, multiply by 7, 7 4s are 28, 87 plus 28 is 115, take the unit digit, 7 5s are 35 plus 11, 46. 46 is divisible by 23. So 8464 is divisible by 23. I hope you are enjoying finding out the divisibility rule for any prime number. Idea clear, right? Next one. Now you can keep on doing, sir. I don't need to do. I don't need to do anything. Divisibility rule for 29. AB is nothing but a plus or minus k into b is 0 or ab. 0 or ab. You only tell me 29 means what will be the divisibility rule? 2 plus 3 into 9, which will give you 29. So what is the divisibility rule for 29? It is a plus 3b. It is a plus 3b. For example, suppose 7569. 7569. A plus 3b. 9 3s are 27. So these 783. Take the unit digit, add, multiply by 3 times. 7 3 3s are 9. 87. 87 is 3 into 29. Idea clear? Divisibility rule for any prime number you can do it. That means 7569 is divisible by 29. Test for divisibility rule for 37. Already we discussed multiple methods. 10 power 3 divided by 37 is 1. This one concept we discussed. Any single digit written p minus 1 times, any single digit written p minus 1 times is always divisible by p, is always divisible by p if p is a prime number, p not equivalent to 2, 3 and 5. 2, 3 and 5. Now another rule, 37 is nothing but a plus or minus k into 7. Either it should be 0 or it will be a 37 or its multiples. Now you only tell me, sir. Suppose if I take 3 plus 7k or 3 minus 7k, which number you are getting it? Either it should be 37 or 74. Suppose k value 10, k value 1, 10, 14, 17, k value 3, 21, 24, k value 5, 35, 39. Now you only tell me which value of k will satisfy this number. Here if you observe closely, k level will satisfy because 3 minus 7 into 11 is minus 74. Minus 74 is divisible by 37. So what is the divisibility rule? Divisibility rule a minus 11b. A minus 11b. I hope you are understanding how am I defining the divisibility rule for any prime number. I hope it is clear. Suppose if it is 999, 9 multiply by 11 times, 9 11s are 99, 99 minus 99 is divisible by 37. A minus 11b is the divisibility rule. Idea clear, right? Just it's a matter of finding what is the value of k. What is the value? Method 1, method 2, method 3. Not a single doubt my student will get in any topic that I teach in aptitude. If you follow regularly my class, if you attend my classes, you will be 10x times better than anybody in the topic which I teach. I can bet it with confidence, right? Next one, test for divisibility rule for 31. You can teach the teachers also the concepts if you listen to my class. Watch divisibility rule for 31. Watch this class. Go and teach the teacher, right, how a divisibility rule for prime number can be obtained. AB. A plus or minus k into b is either 0 or AB. 31. This can be written as 3 minus 3 into 1 is 0. So the divisibility rule for 31 is a minus 3. Are you all with me? Suppose for example, now I don't think any student has got a doubt. 8649. Take the unit digit multiplied by 3 times. 27. It is 837. 7 3s are 21. 83 minus 21, 62. 3 2s are 6. 6 minus 6 is 0. 8649 is divisible by 31. Are you all with me? If the digits are more, use that concept of any single non-zero digit written p minus 1 times is always divisible by p if p is a prime number, p not equivalent to 2, 3 and 5. Divisibility rule for 43. Theory of oscillation states a plus or minus k into b should be either 0 or AB. 43 is 4 plus or minus k into 3. It should be either 0 or it should be divisible by 43. If I take k value 13, so these is nothing but 4 plus 13 into 3. 39 plus 4 is 43. So answer is divisibility rule for 43 is a plus 13b. Are you all with me? A plus 13b. For example, 1849 is there. Take the unit digit. 9 13s are 117. Hey, again it will be 301. Multiplied by 13. 30 plus 13, 43. So 43 is divisible by 43. Answer is 1849 is divisible by 43. Idea clear, right? Divisibility rule for any prime number. Divisibility rule for any prime number. Divisibility rule for 47. Theory of oscillation is a plus or minus k into b is either 0 or AB. 47 is nothing but 4 plus 7b or 4 minus 7b. 4 plus, here we will write like this, 4 plus k into 7 or 4 minus k into 7. I am not going to solve this problem, right? Or if you want, I can solve the problem. K is nothing but 14. 4 minus 14 into 7. 94 minus 47 is 94. 94 is divisible. So the divisibility rule for 47 is a minus 14b. Are you all with me? Example 2209. Take the unit digit, multiply by 14. 9 14s are 126. It is a 94. 94 is divisible by 47. clear idea for any divisibility rule for prime number based on theory of oscillation. Some advanced level questions. Most of the students who do not know this logic, you will think that next two questions are Olympiad level questions, but it is not Olympiad level question. ABC is a 3-digit number, okay? AB plus 2C is 19P. DEF is another 3-digit number. 3-digit number. DE minus 3Fs are it is. 3F is nothing but 31Q. Now if I take AB as some number X, X plus 2C is 19B. Can I say that that is nothing but the divisibility rule for 19? Yes or no? Instead of giving a AB, he gave ABC. I told you that A is any digit number. AB, if it is X, X plus 2C. X plus 2C is nothing but the X plus 2Y is nothing but the divisibility rule for any digit which is of the form XY. So that means ABC is divisible by 19. Divisibility rule for 19. If I call DE X minus 3F, it is 31Q. Can I say that it is nothing but the 31 divisibility rule is X minus 3Y only? Are you all with me? That means DEF is divisible by 31. DEF is divisible by 31. Answer is 19 into 31. Are you all with me? It is an absolute sitter. If you know how to find out the divisibility rule for 19 and 31. 19 means by this time a student who is watching the video must have understood. 19 is nothing but A plus 2B. 31 is nothing but A minus 3B. That is what he gave in the question. So ABC should be divisible by 19, DEF should be divisible by 31. 19 into 31. Are you all with me? Whatever the answer that you get, that itself is the answer. Next is a cat level question. Without keeping pen on the paper, my student should solve it. That is what I expect from every enrolled student. ABC and DEF are a 3-digit numbers. AB plus 2C, that means it is divisible by 19. DE minus 3E, it is divisible, I think same question, 589. 589. It is actually a 5 minutes problem. I translated into a 10-second problem by giving you a thorough idea of how you can develop the divisibility rule for any prime number. I hope the idea is clear. What are the concepts that we discussed today? I will just repeat the concepts. What are the things that we discussed today? We discussed the how to find out the divisibility rule for K minus 1. I hope it is clear. Digital sum can be used for any base system K. Digital sum can be used for in any base system. That is what we discussed. Then we discussed the divisibility rule for 7, which is A minus 2B. Then we discussed the divisibility rule for 13, A plus 4B. Then we discussed the divisibility rule for 19, which is A plus 2B. Then it is A plus 7B. 29, A plus 3B. 41, A minus 4B. Like that you can develop your own divisibility rule for unique.